The next session is going to be about how we can use natural languages to interact with our orchestration systems. So Sahithi and Viktor is going to give us some better insights into that. So welcome up on stage.
Right. So we're going to talk about language-driven orchestration, a little bit about how to interact with NSO using natural language. There was a very good talk by Javier before lunch. I'm not quite as smart as him. I have much, much simpler goals in life. I might want to make things simpler. So easier for me and easier for you. So network automation used to be a little bit complicated. This is an old Cisco price list. Send in your router to Cisco, pay $500, and we will fix the software configuration for you. It's still kind of complicated, right? As we move forward with network automation, we can do it ourselves, but we sort of need this expert brain. On an earlier version of the slide, I had a title, Your Brain on a CCIE, because there's a very special breed of people who really understands routers. And once again, I'm not as smart as you people are, and I need to simplify it. And if we look at what we're doing with this project and what our goal generally is with NSO, it is to try and move in that simplification direction. Try and replace this sort of network assembly language with more principles. Now, pretty much everyone here knows quite a lot about NSO, but I do want to hit a few of the points that are different with NSO compared to what a lot of people do. And the main thing we do with NSO is we try to impose an order. And we always manage to impose some kind of order. All the data we have is organized in a database according to a schema with reliable paths. We have models for everything. We have APIs for everything. And just that sort of almost beginner level of order means that we get some advantages. Because a common mistake is to get rid of structure, to say, oh, it's all strings anyhow. And a lot of the things when we fight with introducing NSO, with introducing network automation, a lot of that problem is about people thinking in CLI strings. And I think that if you have that expert brain, that's sort of natural, you spend a large part of your life thinking in terms of those CLIs. But as Javier was saying, right, as you move up the stack with abstractions, as we start thinking of the business intent, we leave that behind. The customer intent is never expressed in terms of Cisco CLI or another vendor CLI for that matter. So for us, having that order brings us one step closer. Of course, if we do our job right, we start having advanced services that give more and more abstraction, and so we get closer to that goal. And my opinion is that the better our data quality is when we begin our AI work, the easier it becomes. Because if the AI is to infer business intent from raw device config, we have a long, long way to go. So with that in mind, right, let us talk for a moment about the tools at our disposal and what we've been using in this project. So there are a few things in sort of the basic toolbox. And I saw the poll when Javier was talking, and I know that some of you know quite a lot about this already. And I'm no expert, so once again, I'm trying to use very, very simple words. So the basic thing you can do with an LLM, when you go to something like ChatGPT, is what's called prompt engineering. That is setting a context, making sure you're asking in the right way, that you ask the LLM really, really nicely to do the right thing. Because context is always happening in some kind of larger context, right? You have a question in a context, in a context, in a context. And the more of that you can provide to the LLM, the more results you can get. And so the next step, what's called retrieval augmented generation, or what some people just call RAG, is that way of providing more context, that before you call your LLM, you do a search to try and find relevant information. to try and build up that context as well as you can. You can do this through things like vector databases and embeddings and all of these sort of auxiliary tools to LLM. And in many ways, all of those tricks are almost as cool as the LLMs themselves. So with RAG, you can get quite a lot of value out of LLM. And the next thing that you can do is fine-tuning. And we talked a little bit about it before lunch, and Javier said he was kind of doubtful that we needed fine-tuning. And I spent some time this spring looking at what AI projects do within Cisco. And we don't see a lot of very efficient fine-tuning. I would say that in general, we do very well without it. But there are some cases where it turns out that fine-tuning is useful. Not when it comes to things like network knowledge, but more when it comes to the ability to translate into, for instance, a SQL command where you might need extra information. But what is really coming is this sort of agentic approach, thinking of it as an agent. It's easy to think that the LLM itself will solve everything, but it won't. And what you can start doing with this sort of agent approach is to start letting the LLM do the task it does really well. It is really good at classification tasks, it's really good at translation tasks, but it's not very good at formal reasoning. It's not very good at running such algorithms. And Javier talked a little bit about numerical algorithms, but there's other stuff that we can do. There is stuff like graph algorithms, where we know really well, right? The computer science research has done some really amazing things over the last 20 years in terms of reasoning systems. And connecting the LLMs with that, teaching the large language models to use tools is sort of the next step in evolution. And what we're going to talk about today, and what Sahithi and her team has been working on, is an agentic approach trying to teach the LLM to use tools. So what have we been working on? We've been working on what we call a language-driven orchestration interface, the attempt to lower the bar for NSO users. Now, a lot of you in here are almost too good at NSO, and you might not see the huge advantage of some parts of this. If you ever look at usability, right, there's a difference between how hard something is to learn and how good it is once you've learned it. So if you're the kind of person who memorizes CLI commands, then once you memorize the CLI commands, they are generally faster than typing out the same thing in natural language. But you spend a lot of time learning those command lines. So we're hoping that using this will allow beginners to behave more like experts with just a little bit more time. And we focus on 3 use cases in this prototype. We're going to talk about documentation, doing Q&A and questions out of the NSO database using natural language, and working on the UI and launching the UI based on human questions. And I'm going to hand over to Sahithi for just a moment to talk about the things that have been implemented and how they work together. And unlike all the other cowards who are too afraid to do a live demo, we will do a live demo. What could possibly go wrong, right? I'll see you in a moment. Thank you.
Thank you, Viktor. So I will be diving into a little bit into technical details of language-driven orchestration interface. So first, let's talk about how we prepare data for this agent or application, right? So I want to emphasize that, we don't hard code any of this data. We have gathered data from different sources, like NSO Field Forum. It's an internal field forum where the NSO users interact with NSO experts. They ask questions, and the experts answer in natural language. And we have gathered data from NSO documentation, which is provided by the platform team, and the Yang files. So how do we prepare this data? Let's take an example of NSO Field Forum. So this data is in unstructured format in the WebEx chat. What we do is we extract the raw data from the WebEx, Using the metadata provided by WebEx, we structure that data into a conversation, and we send in that data to a LLM and ask it to summarize what exactly would be the question and answer for that conversation, right? And once we get the question and answer from the LLM, we actually convert that into an embedding and store it into our vector database. So, OK, what is an embedding? Embedding is essentially a vector format of a sentence. So when I say vector, you could consider that like a point in a coordinate space. For example, in a 2D coordinate space, it would be represented in the form of x and y. Here we have multi-dimensional coordinate space, so you would have list of numbers, right? So here we have used models like Distilbert for doc collection and MPNet base V2 for our config and UI collection. These have dimensionality of around 300 and 700 plus. So once we get all the question and answers from our field forum data, what we do is we convert them into embeddings, build our knowledge base in our vector store them in collections. So the field forum data goes into the doc collection. When I say collections in vector database, the collection, you could think of it, it would be something analogous to a table in relational database. It is isolated, and you could have different collections for our different use cases so that you can query just that collection. So once we build the knowledge base, we can run our application. OK, so this is the architecture of our application. We have multiple components. We have the UI component, which is we have used React for our UI. We have used Fast API framework to build our API server. We have used Python as our base language. Then we have used LangChain framework to interact with the vector database and LLMs. We have support for OpenAI's GPT. We have tested with 3.5, 4, and 4.0. If you want to run the inference locally, we also tested with Mistral. We have Chroma for our vector database. Now let's go to the user flow. So once a user asks a question, either via UI, they can interact with the agent, either via UI or through API. Once they ask the question, it goes to the integration hub. It is the integration hub which interacts with multiple components. First, it sends the query to the decision engine, which decides what type of query it is. Is it a UI query, config, or a doc query? Once it determines what type of query and determines the set of steps it needs to execute, it sends it back to the integration hub. It is the hub which actually executes all the sequence of functions, right? So let's take an example of a config query. Let's say user asks a config query. It decides it's a config query, and the hub actually spins up the config agent. And it is the config agent which goes and talks to the database. It then gets the data from the database, talks to the LLM, determines the path which it needs to query NSO, and sends it back to the integration hub. Then the hub executes the query against the NSO running database, gets the config, and sends it back to the API module, which either can be displayed or can be returned back to the user. So let me actually do a small demo. Let me connect this so that we can visualize whatever I have spoken about. OK. I don't see the screen coming up. I'll retry to act.
There we go.
OK. Let me re-add again. All right. Perfect. So let me log on to NSO. So I have the older version of NSO 616. Let me launch. Why is the... OK. Much better. Let me launch the application. All right. So this is our web UI. Let me ask a question. So first, I'm going to ask a config question since we are going through the config flow. So I have an NSO running on my background server. I have attached it to this chat interface. And I have two devices loaded onto it, PXR0 and PXR1. So I'm going to ask it to display what are the devices which I have on my NSO. Let's see. Right, so we are able to see the devices which I have on my running database and running config database, and you can see the XPath which was generated by the LLM. So going back to the presentation, so I can just... All right, perfect. This is good. Similarly, if it determines it's a UI agent, UI flow or a doc flow, it goes through this similar process. Now I'm going to dive deeper into how we have implemented the NSO config retrieval flow, right? So first, let's talk about how we have prepared the knowledge base. So we have users' custom Yang files, and we have some inbuilt Yang files which NSO supports out of box, like devices Yang. So what we do is we collect all that Yang and convert them into XPath. So how we do that is there is a tool called Pyang which we use, and there is an open source plugin which we modified and use that plugin to convert these Yangs into XPath with descriptions. And these descriptions would be in natural language. We have used the description field in the Yang file to, we have leveraged that to create these XPaths. Each of the field would be represented as an XPath, and we have converted them into embeddings, and we store them in our vector database. Once we build our knowledge base, now let's go into the flow. Once the user comes in with a config query, we use something called a multi-query approach. I'll dive into it later in the presentation. So that approach actually gives us a diverse set of XPath. And once we generate this set of XPath, we ask LLM to pick the right XPath for the user's query, and then generate the final XPath as requested by the user. Once we get the customized XPath, we then send it back to the NSO connector, which then uses NSO's RESTconf query API. So NSO's RESTconf query API is pretty good, which takes in XPath expression as input, and we have multiple requests we can do with this query API. We can use start query, which can chunk the data which we receive. Here we use immediate query request, which gives us the response in a single shot. And once we get the response from the NSO, the config data, we send it back to the hub. Moving on. Right. So this is the AI agent design, the multi-query approach I was talking about. So at first, when we went with regular prompt chaining and few other ways of trying to get the XPath, we did not have great consistency. But with this approach, we were able to get some robust results and consistent results for our natural language queries. So here, what we do is once we get the query, we ask LLM to generate few similar queries. And once the LLM generates similar queries, we query against the vector database, which gives in the related XPaths. We aggregate all the XPaths, use that as a context to these generated queries, which we ask LLM to pick the right XPath for the generated queries. Then we have this set of picked XPaths, which we use as a context to the original query. And then we ask the LLM to pick the right XPath for the original query and modify it as per the user's actual query. So once we get the final XPath, we send back the response. All right. So for our demo, I have chosen a model from segment routing package from Crosswalk Network Controller. So this is the tree format of the model. We have the ODN template. I have already loaded few templates into my running database. We have, I guess, yeah. This is the XPath with descriptions, how we have converted into XPath with description. This is loaded into our vector database. And that's the template which we use, the immediate query template which we use to run against NSO to gather data. All right. Moving on. I'm going to start off with some documentation queries. And I think I need. All right. Perfect. So first, I'm going to ask a novice question like, how am I going to enable a hide group in ncs.conf? This might be something easy for all of us, but for somebody who is new to NSO, there should be some place in the, I guess, in the man pages. And you can see that it has given the snippet on what we can add in our ncs.conf and how we can do NCS reload to apply that, and how we can unhide and see the hidden details. Now I'm going to ask a question which was asked in NSO field forum data. Not the exact question, but something similar. So something like, which version of NSO has the log4j vulnerability be remedied, right? So let's see. So you can see that I believe one of the NSO experts might have answered this, so it has picked up from there. It says it has been remedied from 5.3 and so on, versions. OK. I heard that this is a pretty frequently asked question, which is like, how do I check the health of NSO? Let's see. OK. I believe this is from our NSO documentation. And you can see that it correctly points out NCS status is the command which we can use to check the health of our NSO. And I think it also speaks about how you can check the health of our Docker, NSO Docker as well. Now moving on to config questions. Let's do some config questions. We've seen how we can display the list of devices. Now let's see whether it can actually create the XPath with a key. Right? Now I'm going to ask it to display config for a specific device. All right. Come on. Oh, OK. So we were able to get the config for the whole device. We get the ref counters and stuff. But this is what NSO replies for our immediate query. And this is the XPath, which is correct in retrieving the config. Now, I don't want the whole config. Maybe I've written a wrong IP address. I just want to see what's the IP address of my device. So I'm just going to ask, what's the IP address? You can see Decision Engine decides that it's a config query, and And the tailf address is .18. Now moving on to some custom templates. So I've loaded some data from SR templates as well, the segment routing ODN templates. I'm going to ask if it can display me all the SR ODN templates which I've loaded into my running database. Okay. Okay, these are the 5 templates I've loaded. You can see all the configuration, the head end, the color, and everything over here. Now let me ask a little bit complicated query and see if it can answer. So what if I want to filter out the data? Like we have color between different ranges. I would say, OK, give me the template names whose color is between 0 and 2000, right? So let's see if it can construct a complicated XPath like this. OK. Oh, OK. Let me look at the XPath. Right, let me ask the same question again. I hope it answers me this time. All right, now we are able to get the answer. Yeah, so looks like the second time's the charm. So we get the XPath where the predicates to filter out the color between 0 and 2000 are written over here. I've just now moved to GPT-4o. I guess maybe that's why I see the no data. All right, these are the config use cases I wanted to demonstrate. Now let me show some UI use cases. What if I don't want to see all the data on this interface? I want to say it in UI, which is much prettier than this. So I'll be like, show me the devices in UI. So it should be able to cross-launch into UI and take me to the page where the devices are present. The same thing I'm going to run with our SRODN. Let's say I want to see all the templates on our SRODN. OK, awesome. Now, I can navigate to any place from here. Now, I would want to see a template for a specific name or a specific key, right? So let's say I want to display details of a specific template. So it should take me to the UI of L2NME VPN, and you can see it has done that. Then I can see all the details from here. Yeah, perfect. All right. Now I'm done with looking at the configuration. Now I want to edit something. What if I want? It's hard for me to navigate or click through all the buttons. I just want to say, hey, I want to edit my device, some details on my device. So it would take me to a form where I can edit all the details on my NSO UI, and I should be able to edit anything I would want. All right. So you can also see the logs, like how we have the NSO query and the endpoint selection with proper key and everything. Now, I don't want to deal with all those form elements. I want to go to a specific element and change it, something like an address. I want to modify the address in my POS6R1 device, and I'm going to actually do a live modification here. I'm going to make it 10 in honor of our Cisco 10th anniversary. OK, where are you? All right. All right, I see the change. Let's commit. OK, we have committed. Now I'm going to validate whether device has, the NSO CDB has been updated. we have the updated address on our NSO. So that's for the demo. Let me go through a little bit of what we have been doing here. So this is the server messages which we have printed out so that we can understand what's been going on in the background. So once we have a query in, for example, here the request is SRODN template names whose color is between 0 and 2000. It goes into decision engine where we determine it as a config query. And you can see the XPath collection it has. It has a lot of XPaths which are unrelated, but we just leave it to the LLM to pick the right one and modify it such that it would adapt to the query which we have asked. And you can see the generated XPath in the purple color. I did escape some characters for XML. So you can see the proper predicates and how we have the final XPath, which we query against our running database. And you see in the red box the configuration which NSO sends back. So I guess that's it for my demo. Back to Viktor.
Thanks. So there are a few really interesting things here, right? Because first of all, we talked about SRODN here, but we don't have any hard-coded information. It's based on the Yang model. So if you've written good description fields like we have, and that's what was driving this, we could take these services in your system and load them in and get a similar result. The same thing goes for the UI here. The UI stuff, the URLs we generate are also schema-driven. So in a similar way, we can build up a knowledge base of URLs based on the schema. So the stuff we've been doing here is fairly general, but also fairly limited, right? We have a narrow scope in the language-driven interface, trying to build on some of the stable stuff we already have. We're building on the auto-generated URLs and APIs and the models, building on the query API. And I mean, even if you don't use AI, the query API is really, really useful for getting data out of NSO. I spoke about it briefly yesterday in another session, but it's sort of a SQL interface to the database, letting you pull data out. So the goal here, right? Try to help beginners be experts. Try and share a little bit of that sort of user experience. Early days, we're still exploring. We really value feedback on this. Would love to talk to you over the next few days. I want to end with acknowledging the team. We have been talking a lot here today, and we'll keep talking over the next few developer days. But there's a lot of hard work in the background as we come up to this point. So thank you very much for listening to us for half an hour. I hope that you have had just as good of a time as I have. And see, live demos are harmless, only one mistake. Which is about average, right? We've been very lucky in this approach that AI actually ends up delivering fairly stable results. And using this query API in the backend means that we limit hallucinations a lot. So it will sometimes come up with a no data or an I don't know, but we haven't really seen any crazy responses out of the AI. I'm sure with some work, you can jailbreak it and make it do some weird stuff, but sort of a good faith use has never seen anything that was out of pocket. So, thank you very much. And any questions?
Yes, absolutely. Ooh. We have a very active audience posting their questions. I can read some of them for you.
And aside here on the XPaths, right, as you saw in the demo, right now we always query the XPath, but there's sort of a sub-task here of generating the XPaths. And right now in the demo, you can in a log that they've added see the XPath, but of course, you can then copy-paste that for other users. You can imagine easily adding a mode where you only get the XPath instead of the data.
All right. Let's do like this. I'll promote them up on the screen. Let's see if it works.
Okay.
Here's a question.
So we're not using TAC tickets, and there has been some work within TAC on using TAC data to train AI assistants. We haven't done it for a number of different reasons, because one is the integrity problem, that TAC tickets tend to include customer data, and we don't really want to train our system on customer data. We would have to go through a cleaning process, and I do get pretty annoyed with our lawyers, but I think it's a good idea to not send customer data to the internet overall. So there might be a technical support AI. It's a little bit in the future for those kind of integrity and privacy reasons. We have a fairly strong responsible AI framework that we need to follow. But we are going to use sort of our internal stuff for building this, where it's easy to clean out and I think customer specific.
All right, we have some more questions. I'll just try to send them on the screen. Yeah, here's another one.
So the system can't do it right now, but it will be fairly easy to add. And you see a little bit of it in that log. Yeah, not available, no roadmaps here. We will talk, you can pass to the PLMs later. But a lot of it for us is that we don't quite know yet what is useful for you. So if you help give us more feedback, and we'll know what is worth investing in. It takes, unfortunately, there's a big difference between a cool prototype and a live product, but Yeah, and this is similar to the previous one, right? Right now we get the data, but it would be very simple to just show it instead of actually doing it. So I think it could be a helpful tool. And that's one of the things we do want feedback on more generally, that if you want to use a tool like this for development, what would you like? Export generation is definitely something that we have here, but there might be other stuff that is really useful. We would love to hear about it. Either, maybe not right now, you can find us tomorrow, or we have a PLM session and stuff like that. So yeah, do let us know what is useful to you.
It's a question about netconf neds.
Yes, so if the problem is, are the descriptions good or not? Because as Sahithi showed a few slides ago, and I'll actually go back, I think I have it. So what happens here, right, is that we start talking about describing the X part using the description fields out of the Yang model. So as long as you have a Yang model with good description fields and fairly unique descriptions, right? If you have IP address in 20 different spots in your model, and you ask to find the IP address, the LLM is going to have a very, very hard time to figure out which particular node you need. But if you have a description that says this is the IP address for the management interface, and you ask for a management address, that's fine. But it does require you to have a certain amount of data quality. On the other hand, if you get problems with AI that require you to make your Yang models better, that's not a particularly bad thing, right? It might be a problem with vendor-provided models, but with your own, it's pretty easy. So long answer to a short question, yes. This will work for netconf neds and finding the parts.
All right, very good. I think
Thank you very much.
We're out of questions, so let's give a round of applause. Thank you so much.
Yeah, we'll do that later.
Some nice answers.